everyone. I'm gonna talk about Kubernetes again. 2 weeks ago, Omura-san had a talk about the same topic, and this talk followed the talk, Omura-san talk. Okay. Today's agenda is here, and I'll talk about pods and ReplicaSet deployment and jobs. And last, I'm going to talk about network between services or pods. Okay. First of all, I recommend you to install Kubernetes on your local machine. It's very simple. You need to install only kube control and Minikube, as you see. And after installing them, you need to start Minikube Kubernetes cluster, and you can use kube control. Here is a pod YAML file. This is very simple. This is very simple pod. There is a Docker container, and this container uses Ubuntu Docker image. And in that container, every 2 seconds, some message are shown. Okay. For example, this YAML file is saved as example echo.yaml. Then we need to apply the file to the Kubernetes cluster. Next, we can see the resource status by kube control get pod and the name. Kube control get accepts -o option. With this option, output format is changed. Okay. And kube control has describe command. This shows more detailed information of the resource. As you see, there are container ID and image, command, arguments, and events. Okay, this is very useful. And kube control has logs command. Logs command shows standard out and standard error of the pod. As you see, there log every 2 seconds. This pod write a log, and we can get a shell into the pod by kube control exec. As you see, bash, and in the container, creating a file, then this command show /temp /message.txt, so there the message. Okay. This is next example. this is a little complicated, and there are resource limit. Resource limits and requests are to control resources used by a pod, and we can specify CPU and memory, and requests are used by Kubernetes scheduler. So the scheduler think which node is best node to put the pod. In addition, CPU and memory, we can specify GPU resources. Kubernetes supports device plugins, and NVIDIA have device plugin for NVIDIA GPU. We can use the device plugin with these softwares. For example, this is a pod example, and this pod shows you files in /dev and NVIDIA SMI output. After running this, you can see two GPUs. We requested two GPUs, as you see, and NVIDIA SMI shows two GPU status. Okay. Next, pods can have volumes. Volumes means first of all, files in pod are ephemeral, so it can be deleted. But with volumes, you can store the data as persistent data, and it can be used to share data between pods also. And Kubernetes supports so many types of volumes. The most famous one is host path. Host path means somewhere in the node. And in addition to it, CFS, GlassFS, NFS, AWS, EBS, Azure Disk, and so on are supported. This is an example for host path volume. And as you see, this pod mounts /host in the host and into a /mount host. So from the container, we can see data in /host from /mount host. For example, first we create a file in the Kubernetes host node and applying this file, and then you can see this file. Okay, next is config maps and secrets. Sometimes we need inject some configurations into an application. These are for injecting into a pod. Config map stores configuration data such as nginx config or something. It is not confidential. And on the other hand, a secret stores confidential data, such as a password or something. And they are readable from pods as an environment variable or files in volumes. Here is an example. This is an nginx pod, and this mounts config map as config volume, and this mounts config volume into user share nginx HTML. This is a config map, and on the other hand, we use secrets to by this manifest, secret can be readable from readable as an environment variable named very confidential password. And we need creating a secret and creating a config map. Then create a pod, this pod. Then you can see this HTML. This HTML is stored in config map. Okay. The next is deployments and replica sets. This is for running for long-running applications such as web services. For web services, we need to keep multiple replicas to keep the site available. Replica sets keeps one or more pods running state, and the deployment manages these replica sets. For example, this is example deployment. Deployment contains a pod template. Here is a pod template, and with this deployment file, we can see one deployment and one replica set and 3 pods. In this deployment, number of replicas are set to 3, so we can see 3 pods. And I can access to the nginx pod, 3 pods. Okay. And deployment supports updating resources like deployment for new version application. If we edit the deployment file, Kubernetes will create a new replica set, and new replica set will create some pods. In this example, we see 2 replica sets, and there are 5 nodes The top two is new version, and the bottom three are old version. One of them is terminating, and new version is running and content creating. This is useful to deploy new version. Okay. Next is job. Job is like ReplicaSet, but ReplicaSet is for long-running application. But job is one-shot job for one-shot job. A job creates one or more pods and ensures that the specified number of them successfully terminate. And you can see the detail at this URL. Okay. The last thing is communication between pods. In Kubernetes, every pod can communicate on IP layer. Every pod has its own IP address. So in the previous slide, all pods has their IP addresses. Okay. And in addition, the pod IP and service can have an IP address too. Service is a set of pods. So by service by cluster IP, we can connect to one of them, one of the pods. This is an example. Here is a service, and this have a selector app nginx. So this service, this service sends a request to a pod which have app nginx label, and create this, and this is the service IP, and 3 times curve. You can see 3 different response. This means every request sends to every request are sent to a different pod. Okay, that's all. And there is an official document. This is very useful, so please read it. Thank you. Any questions?
Have you run Chainer on it yet?
I ran Evanist only.
Okay.
Yeah.
How, like one node?
Yes.
How did it go?
But it's good. But Omura-san has Chainer MN example, so we can run on multiple nodes.
Do you have an idea of the overhead that Kubernetes runs? Is it pretty light?
Maybe Omura-san had it.
Okay.
Yes, Omura-san. Yes,
Hi, this is Omura. I'm not sure how much overhead exists in Kubernetes. Maybe disk access or network overhead exists, but yeah. we need some benchmark.
What volume? What is the better solution to manage on different clusters like local mini-Kuben and distributed cluster? Should we separate YAML file? We will run on different distributed clusters. I think Postpass cannot be used.
You mean host plus is for specific node, so it can be shared? You mean?
I want to use same YAML file on different clusters. If the environment of them same status, we can use the same YAML, but there are different clusters. We need to create 2 files or so.
Just FYI for everyone, we will have a Kubernetes conversation. So if you are interested, then please sign up. I'll share the link of the
Any other question? Okay, thank you.